Alright, we are starting to look at polynomials. The first thing is some vocabulary. So a polynomial with one term is called a monomial. And an example of a monomial is if I had 5, there's one term. Or if I had x, or if I had xy, they're grouped together, so that's one term. Even if I had x, y, z, that's all one term because they're all being multiplied together. So that is an example of a monomial. An example of a polynomial with two terms is called a binomial. So this is like if we had 5 plus x. So putting two terms together by adding or subtracting them. Or if I had x squared minus 6. That's an example of a binomial. A polynomial with three terms is a trinomial. So this would put three terms together, so x squared plus 3x minus 4. There's an example of a trinomial. And then last but not least, exactly what we're talking about is a polynomial. So polynomial is anything with more than three terms. We talk about the degree of a polynomial by looking at, so the degree is looking at the term with the highest or largest exponent. So if I look at the examples on here, example 1, I have x squared plus 3x minus 5. My largest exponent is on the x squared, so the degree of this trinomial is 2. On example 2, this is all one term, so their degrees go together. So the degree of this, if I add them, is 4. Oh, and you can't see that, so let's see if we can get this fixed. Alright, the one thing that when we talk about polynomials is that we want to put them in standard form. So I'll be saying that a lot in class, that it needs to be in standard form. So what that means is that your terms have to be in order from greatest degree to the least degree. So your highest exponent into the lowest exponent. So an example would be if I gave you 3x squared plus 6x to the 4th minus 2x to the 7th plus 4. I would want to put this in standard form, so I would look to see which one has the highest degree, so the highest exponent. That would be the negative 2x to the 7th, that would go first. And then I would go in descending order. So the next one is 6x to the 4th plus 3x squared plus 4. So this right here is our standard form of that particular polynomial. We can classify our polynomials by their degrees. If the degree is 0, it's a constant. So an example of that is just a number. So if I had a 1 or a 0 or a 6, that's a constant. If the degree is 1, that's a linear function. So that's like all of the linear graphs that we've had. They've all just been an x or 2x. Their exponents were 1, therefore that made it linear. Quadratic is if we have an exponent of 2, cubic, an exponent of 3, quartic, exponent of 4, quintic, exponent of 5, and then if it's 6 or higher, then it's just labeled as the 6th degree or 7th degree. So x to the 6th would be the 6th degree, x to the 7th, and so on. So we're going to look at these examples and we're going to classify them by their degree, so the name of the degrees, and the number of terms. So in order to classify them by the degrees, you have to look at the highest. So the highest in example 3 is 2. So when it's a degree of 2, it's a quadratic. And then there are 1, 2, 3 terms being added together, so it's a quadratic trinomial. from above. So I want y'all to try example 4 and 5 on your own. Go ahead and pause it and then check to see if you got the correct answer. So let's see, example 4, the degree is 1, so it is a linear, and there are 1, 2 terms, so that's a linear binomial. Alright, example 5, the highest degree is 7, so this particular example is not in standard form, so you need to look at the highest degree. That is the 7th degree, and there are 1, 2, 3, 4 terms, so that entails it to be a polynomial. So that particular example is 7th degree polynomial. Alright, moving on, we're going to look at example 6. Example 6 says, write an example of a cubic, so that means a degree 3, monomial, 1 term. So I need it to have a degree of 3 and be 1 term. So x cubed is the easiest example that most of you would jump right to. Another one would be if I had x times y times z. So each of their degrees are 1, so the total degree of that monomial is 3. I could also break it up and say xy squared. So again, 1 plus 2 will give me that cubic aspect that I need. Alright, so that is the classification, the vocabulary that we're looking at. Next, we're going to be looking at adding and subtracting polynomials, and your answer needs to be in standard form. With this is basically combining like terms. So they have to have the same letter with the same exponent for them to be added together. So example 7, if I look at 15m to the 7th plus 6m to the 6th minus 9m to the 7th, my like terms are the 15m to the 7th and the negative 9m to the 7th. So if I go ahead and combine those, 15 minus 9 is 6. So that leaves me with 6m to the 7th plus 6m to the 6th. And I can't combine these two because, yes, they're the same letter, but they're not the same degree. So this is going to be your answer. Alright, example 8. We look and see what like terms do I have. I have the 2x squared and the 3x squared. So 2x squared plus 3x squared is 5x squared. And then plus that x. And nothing can be combined. I can't speak. Nothing can be combined further. I'm going to skip and move to example 10 because I want you all to try 9 and 11 on your own. Example 10, the difference with this is that there's a negative in front of the second binomial. So that means you need to distribute that negative. So it's like a negative 1 is there. So if I distribute that, I would end up with a negative 5x squared and a positive 7. Now, after that negative has been distributed, go ahead and combine your like terms. So 2x squared minus 5x squared gives me 3x squared. And then 6 plus 7 gives me 13. So there's our answer. Alright, now is here where I would like you to pause and try example 9 and 11 on your own to check and see if you can get the right answer. Alright, if we look at example 9, if you combine your x to the 5ths, that gives you 13x to the 5th. The next degree that we should use is the x to the 4th, and there's only the 3x to the 4th. And then the last one is the x's. So negative 2x minus 11x is negative 13x. So there's our answer. It's in standard form because it goes from highest to lowest degree. Alright, on example 11, again, this one's like example 10 where you have to distribute that negative to each of those pieces. So this is going to give me with negative 5x to the 4th minus 2x cubed plus 3x. Then we combine all our like terms. So I have x to the 4th minus 5x to the 4th, so that leaves me with negative 4x to the 4th. Let's see, negative 7x cubed minus 2x cubed. That leaves me with negative 9x cubed. And then lastly, the 3x. So again, we combine our like terms and we put it in standard form. So after you go through this, I want you to write down if you had any questions, if you found anything confusing, and what did you learn. And we'll go over those questions that you have in class tomorrow. So good luck and thanks for watching.